Hello and welcome back to another episode of Coding Wizards. Today in this episode we'll be going over a quick function I made called combinations, and then another function called add combinations, which I used to solve a CCC, which is a Canadian Computing Contest problem. So first of all, I'll check out this combinations function. So what this does is it consumes a current string, which in this case, I'll just make a print statement. In this case, it's just going to be an empty string because it's the base case. And then it consumes a list of work, which is going to be letters. And what this function does is it creates the different combinations of essentially strings based on a bunch of characters. So that's pretty cool. How it does this is it goes and starts at the top. First of all, there's a base case if the length of the current string. So the length of the current string in the base cases here is 4 equals the length of the list of work, which is 4. So essentially, if the string is 4 long, in this case at least, then we just create essentially a temp list and then append a string, just so that we can return a list with or an array with the only index inside it is just the current string essentially. We just return that because in the other case, we have the temp list, which is equal to nothing, and then for every index in that in this list of work, we look if the index is in or not to decide whether to add it, because we wouldn't want to add A twice, right? If we had A, B, C, D, we wouldn't want A. We wouldn't want AA. We wouldn't want to keep adding the A because we already consumed the A, and so it checks if it's in that string or not. And then if it's not, then it will add to this temporary list the combinations, which is just calling this function again, of this plus the index. So it will add one of the things on, and then it will essentially put in the list of work so that it can be used in the next functions. And then when it's done, it will return this temp list, which of course, this will probably return to another statement like this, which will then return to this. And eventually you'll get to a statement which returns the temp list in this initial function call. So that's pretty cool. Now there is a built-in library function for this, I forget what it's called, but you don't need to make it. But the reason I did make this one was so I could better understand how this function would work. So there's a problem in the CCC, it is the Junior 5 problem from 2017, the CCC, and what you're given is you're given a list of numbers between 1 and 2000. And what you have to figure out is, given these numbers, how can you add them without using more than one? So how can you add them without using more than one number once? There can be duplicates of numbers though, which means you can use all the duplicates once. But you can't use, like, if there's only one number 1, you can't use that twice. If there's 2 of them, you can use number 1 2 times, essentially. And you want to add them just 2, so add pairs of them. And then these pairs would be then between 2 and 4000, of course, because double this, because you're adding them to each other. And then, but for these pairs, you want to see these numbers. You want to see how many numbers, how many different essentially pairs have the same number. So in this range, how many of the pairs have the same number? And you want to print the highest pair number, and then you also want to print how many ways that is possible. So if the highest pair number is 10, but there's 2 ways to do it, for example, at the value 8 and maybe like 980, then this would be 10, and this would be 2. Or if there's only 1, that would be 1. Or if there's actually 18 ways to do it, be 18. Maybe there's 9 other ways to get that 18. But that's essentially the problem we have to solve. Now, of course, to figure this out, we have to figure out how we can add all the different types of pairs, right? Given this list. So to do that, I created this function, which is kind of like this function, except it's more complicated. So it takes in current element, which is like the beginning list. In this case, base is 0, because you're adding stuff to 0. You wouldn't want to start at 1. That makes no sense, because then you're adding stuff onto 1, and you're not really adding a pair. So really I'm not just adding pairs, I'm adding 0 plus the pair. The pair added, but yeah, 0 essentially means nothing in this case. List to walk is essentially the same thing up here. We're going to give it a list of integers instead, which is combo here. Final length is the final length we want to add. Since I know that we only want to add pairs, so 2, I could just set this to do 2, but I want to abstract function, so I'm not doing that. I'm allowing it to be passed in as a parameter. Empty here is just an empty list for the lost context, which is a lost context accumulator, funnily enough, that essentially says, okay, what elements have we already looked at in this list, so we don't need to look at them again. And then we're passing 0 for consumed, which is the amount of elements that have been consumed into the current element. I originally was trying to use the lost context accumulator as a kind of consumed accumulator, but what you need to do in this function design, I figured out, is that if I'm going to consume this one and go down a level, I also need to make sure all of these ones don't use that number 1, that index 0, which is equivalent to 1 in this list. Basically so that these are unique pairs, which is what we need. We don't just want to be able to use this number 1 multiple times, or use 2 multiple times. So that's pretty cool. Same thing here, if it's base, if final length equals consumed, essentially if we consumed enough so that the final length is equal to that, then we're going to just return a temporary list with 1 appended. Otherwise, we're going to look at, make a new temp list, and we're going to look at a new temporary list we have inside here called current lost, which essentially what it does is has this pattern here where, since I've already consumed this, I want to tell all these other ones in the for loop that they cannot use that. But I want to tell all these ones in there for the recursive calls that they can't use that. And if I didn't put this in so that I could tell them all, it wouldn't work because it would just go down a level, and this would be the only one remembering that, not all the other ones. So I put that there, and the current I, which is the index of it, not the value, not 1, it's 0, which is the index of it, because that way you can have multiple values and they can all be added once. That value will go down. As we can see here, it will be appended, and then this will be the things that you want to use recursion on will be the current lost, which is the this one, and the lost context. The reason I don't go lost context plus equals current lost is because that edit it for all the other ones, which might work, but this is a much simpler way of looking at it. Current element I definitely cannot change because you're adding different elements. If I had current element plus equals index instead of CE, which is just a placeholder, equals current element plus index, what would happen is this one would be consumed by 1, and then it would go do its things, but then this one would go, okay, my turn, but it would already be equal to 1, so it would be 1 plus 2, which is 3, even though the value should be 2, which is not what we want. Okay, and if we continue on, we have the temp list, which basically we just add all the combinations of the other one onto it. So we have this thing where we just walk down, and then this is essentially the way, this and this is the way we walk back up. I have I plus equals 1 to essentially say, okay, we just keep updating the indexes, kind of like in Java, but except that you can't, instead of Java syntax might be something like, for int I equals 0, I is less than x, I plus plus, that kind of thing. And so we have a for loop here, which whereas this keyword, I could assign something else like place, but I called it index. And this essentially takes the value of list to walk I in the list. But I can also have an I value outside just to keep track of the indexes, because it wouldn't actually tell me where the index is, like the number index. It would just tell me the value of the list to walk I. In other words, I don't actually get the I variable to use, so I just put it in, essentially, like you would do in a while loop kind of thing. This says if the index is not in lost context, then you can add it, which essentially says, it's the whole thing like, okay, is this thing already in? Do we have this thing in the lost context yet? Is it like not allowed to be used because we already used it someplace else in this recursion? Yes, okay. Then we can't do it. But if it is not inside, then okay, good. We can use it and then return it. So with this, let's run this. Just ignore this zero thing. we get, ignore this because that was from earlier, we get this result. So I'm printing just the length, which is literally just calling this function with this. And this gives me all the different lengths, essentially all the different values between 2 to 4,000. Now, of course, for the actual problem, the numbers would be much different, but as long as the function works in practice, then it doesn't matter. And the ranges really don't matter too much. So we have all these numbers here, and then I'm going to put them now in a counting sort, and what a counting sort is say we have 2 to 4,000, then we'll have, I believe, 2 to 4,000, we'll have like 3,999 lines would do it, 99 indexes, but essentially we have 4,000 indexes, which is this thing, and we say, okay, so for indexing starts at 0, so you can just ignore 1 really. So for index 3 in the list, okay, we'll go look at index 3, or index, so, here, sorry. So this is, for number 1, we have 2 possible indexes for that, right? So for number, sorry, okay. Okay, no, this is, sorry, I got confused. This is the actual results from it. So 2 appears once, and you get 2 by adding this 1 and this 1, right? And to figure out, in this list how many 2's we have, see, indexing starts at 0, so this would be 1, this would be 2, there's 1, 2. So what the counting sort does, essentially, every time that number, anytime you have a number on a list, so if I have like 58, that index of the counting sort, which we initialize here, that the number index 38 gets 1 added to it. So if we look here, we can figure out the one that has the most of something. So if we look around, we have all these 11s, right? We have so many 11s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 5. Yeah, I think 10 11s. So if we look here, that's the 11th spot. Now we have 10 of them there. And there's a bunch scattered all across the page. I just made a giant one because earlier I was testing a bigger sample. But if I think I still need it high because, yeah, I'm getting errors out of range. Because I have some really high ones in this list, like I have like 2,000 here, and 2,000 plus, what's the biggest one, 982? We do that, that's the same kind of result with, same kind of thing as this one. 1 plus 2,000, actually 2,000 plus 2,000 would give you 4,000, 1 plus 1 would give you 2, so that's your kind of range. So if I was doing the actual problem, I just set this to like 4,001, because as you can see, blank space doesn't really matter in this. And then what I do for this is I look for the largest value in this. So I get 10 here, I believe. Yeah, here, I can check those out. Yeah, I get 10 here. And then after I do that, I take that largest value and I look through the list again and I go, okay, every time I see the largest value, which I know is 10 now, I'll add 1. This essentially means how many different ways can we get it. Because if there's only 1, there's only 1 way. If there's 2, there's 2 ways. If there's X amount of ways, if you see X occurrences of that largest one, then there's X amount of ways that you could build the fence height at that highest length. And then at the end, we just make them string values and print these 2 things. So that's how you solve it. So yeah, pretty cool. Expect more Python and other videos soon. I've been working with Lambda and other cool things in Java, some things in Dr. Racket. Oh yeah, and if you want to get any of these libraries, I'm not using any libraries for this, but if you do, you first of all, you can import, and then in your code, name of library, name of stuff you want, right? And then you can go from the library that you want, whatever, the library you want to take it from. For example, if I go like import pandas, which is a really, really nice thing for creating data frames and any data structures, you can as PD. I could just import pandas and say, okay, I can call things with pandas, but I can call it as PD, so that's like, instead of having to type pandas every time, we can just pandas every time, we can just type PD. Pandas is really cool because you used to have to, like, with open, if you want to read some file, like my CSV file, .csv, and then I have to set it to mode read and stuff, and then I can as file, and then for maybe index a line and file, I have to do things, and then for that, whatever, and then I put in 2D array to get out the data and change the values of types and stuff. With pandas, you can just go my data frame, which is a corner type data structure that exists in pandas, is pd.cs read underscore CSV, and then you just put in the name of your CSV, so like CSV file.csv, and that just reads it and puts it in that. Okay, obviously it's saying I don't have a name, I don't have a CSV file called CSV file, but you get my point. If it did have one, it would read it and it'd be really amazing. I also recommend using NumPy. It's also a really good one for machine learning. Scikit-learn, I believe that's how you spell it, is really good for looking at models like linear regression, logistic regression, decision trees, Bayes theorem, and much more. I think also SVMs, and I think there's a bunch of other ones like gradients, but yeah, those are the main ones that I've been learning. And then for GUIs and UIs, Tkinter is a great resource to use. I believe it comes built in. And oh yeah, I'm using Spyder with Anaconda Anaconda Navigator, which allows me in the Anaconda terminal. I think this is honestly the best Python IDE. You can go pip install, and then you can type the name of what you want here, and it will just download it for you. That simple. To download the library for you. So expect more videos soon about that stuff. I have a black box here and a black box here because these actually have file paths in them, and my name is in the file path because it goes through users, so I just block that out. If you're wondering why those are there. So yeah, expect more videos, and yeah, thanks for watching. Bye!